So today we're going to be just still working with scale diagrams, but we're going to be more specific today, and we're going to be talking about the actual real size in regular everyday life. Now, when you see those model cars, it'll always tell you the scale that that car is. And everything has to be to scale. Like if it's a 142, that means you took every measurement and divided by 42 to get it. But if you took the steering wheel and divided by 30, and the tires and divided by 20, and the windshield and divided by 10, do you see how bad that model would look? So they had to take every single measurement and multiply it or divide it by 42. I was watching a show the other day, and someone had actually built an entire real-life car off of a little Hot Wheels car that Hot Wheels had made. Okay, so the real car didn't exist in real life, but it said under that it was a 1:42 scale. So he took everything on that and multiplied by 42 and made the real one. And he could do everything to scale because of that. So he would do this to be able to do that. Okay? Now, so here's an example of a shark. Now, it would be inhumane, it would be weird, it would be hard for me to bring a shark in. So I'm like, okay, well here's a picture of a shark, and guess how big this shark is in real life, right? So the one we used today was always new over old, okay? That was for when you just have two shapes. But for all of these, it's going to be picture over actual all the time. Picture or diagram, right? Or map, right? The actual will always be in the bottom. So the old will always be in the bottom when we're doing ratios like we did on the quiz, two shapes. But now we're going to be talking about actual things in real life, be it buildings, cars, animals, whatever. It's always going to be picture over actual. Now, it says 1 centimeter represents 0.5 meters. Now, 0.5 meters is, right, meters about that big, so it's about half that. 1 centimeter on this picture represents 0.5 meters of the real guy. So as a rate, you can write it as 1 centimeter to 0.5 meters. Now, why is it a rate? Because different units. Do you remember ratio has an O at the end? So it has no units. So they just changed it 1 to 50. What the heck? So what? You just move the decimal over 2 and obviously you got a ratio all of a sudden? How do they go? Like, why does it even make sense? 1 to 50. What's 50? 50 centimeters. Because this 0.5 meters, if you go kill him dead but don't commit murder, this is right here at basic 0.5. And if we move it 1, 2 to centimeters, right, we would get 0.5, or we would move it 1, 2 to get 50 centimeters. So now it's 1 centimeter in the picture represents 50 centimeters in real life. And do you see how if the units are the same, they cancel, and that's how we get 1 over 50. So if they're the same unit, we cancel. Okay? So now, let's go and do a couple questions. Now, the lengths of sharks are generally measured from tip of the nose to the middle of the tail. Okay? Tip of the nose to the middle of the tail would be about there, right? Okay? Measure the length of the shark in the scale diagram and use proportional reasoning to determine the length. Okay? Now, none of you have rulers, but trust me, this is 9.6 centimeters. Okay? And the question always is how long is this thing in real life, right? Well, if we have this scale, and let's use this one, 1 centimeter is 0.5 meters, and then we're going to put an equal sign. Now we have to pick where are we going to put the 9.6? On the top or the bottom? Top, bottom, why? Why bottom? In real life, is it 9.6 centimeters? Real life, okay? On the bottom, it's real life. That's what I mean by actual. Is this shark actually 9.6 centimeters? No. This is always going to be your picture or diagram. So that's why we know we're going to put 9.6 centimeters, and this is going to be my x. And that makes sense because I'm looking for real. We want to keep real on the bottom. Does that make sense? Real is always, always, always on the bottom. Now, who can tell me how to solve this? We've done a few of these already. What would you put into your calculator? I don't want the answer. How would I do it? Yeah? Okay, so you would go 9, you would bring that up here, and these two would trade, right? So then you would get x equals 9.6 times 0.5 all over 1. And x equals, what are we getting? 4.8. Now the question is 4.8 what? Why'd you pick meters? It's right. Why? Yep. Okay, good, because it's meters here. It should be meters here, right? So we would say the actual length is 4.8 meters. Okay, so here's all the situations we can have. We'll just write them down here. You can have model over actual, or map over actual. Like map is just a scale drawing, or diagram over actual, picture over actual. Okay, so we don't want to ever confuse this. The real life, and you know what I mean by actual, real life. In real life, that's always going to go on the bottom. The picture, map, whatever will always be on the top. Okay? Speaking of maps, there's a map on the next page. Yay. That's why we have to know about maps. Okay. Back in my day, when we would travel, we actually had to use a map. And it sucked, right? Except you could sit in the back seat with the map and you could look how long you had to go on the map and you could find the towns and everything. So I guess it wasn't all bad. But it's just a scale drawing. You cannot fit the entire planet in your glove compartment. So somebody came up with, why don't I do a picture of the world and put it in, or Canada, or Alberta, or whatever. So this would be a map of Alberta. And it always tells you the scale. Okay? So the scale, now just so you know, this is like 1 centimeter. So 1 centimeter equals 75 kilometers. So, you know, when you got to your map here and you wanted to find out, well, what's the distance from, there's Edmonton right there, and you want to find how far to Calgary, you would just measure from here to here and see how many centimeters it was. Okay? Now, if that's centimeters, that's map. That's top, right? And from that, and what you could do is you could take your fingers and you go, okay, and that's about 1, 2, 3, and about a half, right? And you kind of had a sort of, okay, not like now, Google, you find out to the exact kilometer or how many minutes between Edmonton and Calgary, okay? So let's use the line scale to determine approximate length from Calgary to. Okay, so we know that 1 centimeter equals 75 kilometers. Do you see how I did? Picture over real life. I did not put 75 kilometers on the top. Now, I measured it, and from here to here, it's actually 3.6 centimeters. I don't know if you can see that. It's 3.6 centimeters. Would I put that on the top or the bottom? Good. 3.6 centimeters and our x. Okay, so this one we're going to solve just like the 75 is coming up here. These two are trading. So x is going to equal 3.6 times 75. And you put that in, you get 270. And what would the units be? Kilometers. And that's how maps work back in the day. And all the map is, it's a scaled down diagram, right? You have to know math to read maps. What I find amazing is how on earth they made maps like 300 years ago, 400 years ago. Like they made these detailed maps and all they did was like walk them. They didn't have satellites. They didn't have GPS. And how accurate they were. They got the entire world maps and they're like centuries old. So people actually had to walk this stuff and do it. Like I still don't even know, geez, I walked through the forest for 3 hours. How am I supposed to map it? I don't know, right? So they get this surveying stuff or whatever. It's pretty unreal. And now how Google's done it is all from satellite, which, and have you ever like Googled your house? And you can find out if you're outside. My kids were outside when Google came by the one time to do their. Okay, so we're going to skip the next page. We've done enough mapping. Let's, so here, my parents went to New York and they brought back a little Empire State Building for my son. And this kind of reminds me of it. So he's got this little Empire State Building. Now, Tyler's scale diagram of a tower is shown. The actual tower is 240 meters tall. Now, so this is actual. That's how actual. So what would be the scale that we use to draw this? How would I go about that even? Because you think everything's kind of proportional, the clock, everything, it's all proportional. They use some sort of scale to draw this. How are we supposed to find that out? You'd have to get a ruler to actually find out how tall this is in the picture. And because you don't have rulers, but I'll get you some when we do our. It's 8 centimeters tall. Yeah? So how would I find the scale? What scale was used? Okay, first of all, what ratio could we build right now? Or not ratio, what rate could we build? It wouldn't be a ratio because they're different units. 8, we have to be specific, 8 centimeters over 240 meters. Now, shouldn't it be 240 over 8? Why not? The actual is always on the bottom. Now, put that in your calculator and press math, enter, enter. What do you get? 1 what? Yeah, 1 what though? Good. So now 1 centimeter on this little guy here means 30 meters in real life. So you could almost say this base, say this base would be 30 meters tall in real life. Right? Do you see how that works? Every centimeter is another 30 meters real. So we would say 1 centimeter, because it asks in statement form, represents 30 meters in real life. Okay, so as a rate, 1 centimeter is 30 meters. Or 1 centimeter, 30 meters. Remember, these mean the same thing. Now, what would I have to do to make this a ratio? Okay, convert 30 meters to centimeters. So if we did kill him dead, but don't commit murder, we're right here right now with 30. So what would it be if I went to centimeters? How many places do I go? 1, 2. So from here I'm going to go 1, 2. So as a ratio, it would be 1, 2, 3,000. 1 centimeter on this little guy represents 3,000 in real life. Or 1, 2, 3,000. Okay. I don't know if you ever see guys when they're building a house. Everybody who's ever built a house, they use the hood of their truck and they lay out all these drawings and they put their coffee and everything. And what they do is they build a house from those drawings. Well, someone has spent a lot of time on those drawings and says, build this. Okay. Well, obviously he's not going to build it exactly like it looks, because he'd have this tiny little house. Someone would be pretty choked, right, when they show up to that thing, right? And it costs them like $1 million. So it's a scale drawing, and they have to keep everything to scale as they are doing this. So Kylie, from an abstract renovations design for a candy store is to be rented, the scale drawing on the plan is 1 centimeter for every 50 centimeters. Now, so she has plans, and in the scale diagram, it's an 8 by 12 centimeter little square. So what would be the actual measurements? So first of all, write your ratio down. 1 centimeter represents 50 centimeters, right? Now, we're going to deal with each of these separately. Where should the 8 go, the top or the bottom? Why? Yeah, well, it's not new. It's picture. Isn't this a picture? It's a scale. It's just a diagram. So we want to put our 8 centimeters here, and then our X there. Okay, remember this will come up here, and these two will trade. So X would equal what are we getting? 400 what? I don't think it's apples. Centimeters. Check your units out. Now let's talk about the other dimension. 1 centimeter to 50 centimeters equals 12 centimeters over X. X would equal 600 centimeters. Now, my actual room, right? This is actual. So how many, my question would be, how many meters by how many meters would that be? What would be the dimensions? Because this is like 1 meter, right? So how many of these? 4 meters by 6 meters. So it would be 4 of these times 6. Okay? So, and again, if you're getting confused, right? Kill him dead, but don't commit murder. We're starting here, and we're going to go back. 1, 2. Starting here, 1, 2. So that's 4 meters. And this, 1, 2. 6 meters. And that would be the dimensions of that storage room. Okay. Now, what are the dimensions on the plan? So, what are the dimensions on the plan? The plan is the picture or the real? The picture, right? The plan is just a little picture. If the dimensions of the chocolate section need to be expanded by 3.5 times 4.75. So what would be the dimensions on that little picture, on that little plan? How would we set that up? Okay, we have 1 centimeter equals 50 centimeters. We know that. Where is the 3.5 meters going to go? Top or bottom? Bottom? Why? Is this the picture? Is 3.5 meters in the picture, or is that real life? Real life. Real goes on the bottom. There's a problem, though. We can't put 3.5 meters here, because look, units have to be the same. Okay? So we have to move the decimal to right. So that would be 350 centimeters, and that would be my x up there. And the same thing, 1 centimeter equals 50 centimeters, x over 475. Now this would be a good question. How do we solve for x now? It's up top, that's cool, but I need it alone. What do you have to do to make it alone? What would you do with it? You could. That's an algebraic way. Or I can take the escalator and just come up here, right? And you'd get the same answer, though. That was good. What you did, that's the algebraic way. Yeah, multiply both sides by 350, right? 350. Do you see how it would end up there anyway? And then that goes. So you go 350 divided by 50, which is 7 centimeters. Now this one, 475 comes up here, and then the x is all nicely on its own. So 475 divided by 50, 9.5 centimeters. Now, what did I just find? Actual or picture? This is picture, right? This is the picture. So remember, no matter what, actual goes on the bottom. Right? Picture, map, whatever. Scale drawing, any drawing is going to be on the top. Just like it's always new over original. Think no. Okay? New, always over original. And this is always going to be picture over actual. Actual is always on the bottom. I don't know why I crossed the T. Okay? So I want you working on 1, 3, 4, 5, 6, and 10. Okay, and what I'm going to do is I'm going to bring some rulers into the lab. So you'll have rulers, like for number 4, you need a ruler. Or just a minute. Actually, why don't I just give you that way we don't have to hand out rulers. For number 4, this is Eraser Man. He is 4 centimeters tall, Mr. Eraser Man. Now that's not the real Eraser Man. That is just a picture of him. Okay? Oh yeah, true. Maybe it's just best, yeah, if I hand out, I'll hand out rulers. Cool? And you can still measure the little Eraser Man if you want. See if I'm right.